Sample problem 4.8. Okay, we're back to calculations again. For an aqueous solution of glucose, C6H12O6, determine A, the molarity of 2.00 liters of a solution that contains 50.0 grams of glucose. And then part B, the volume of this solution that would contain 0.250 moles of glucose. And then finally, C, the number of moles of glucose in 0.500 liters of this solution. Okay, so in this section, we're introducing something called concentration. Concentration is the amount of a solute divided by the amount of solution. So imagine that you have glucose as the solute. And then the solution is aqueous solution, meaning it's in water. You put amount of. Okay, amount of aqueous solution. Specifically, we're going to talk about a type of concentration called molarity. And molarity is moles of solute divided by the volume in liters, liters of solution. Okay. Sometimes written as N for moles, V for volume, or N for moles, L for liters. It's done in different ways depending on which textbook you're looking at. Okay. So we're going to do this calculation, and I'm going to write molarity with a capital M. And I'll use V for volume, so N over V. Okay? It looks a lot like density. Density is mass over volume. Molarity is moles over volume. Okay, so let's try part A. Part A says that you have 2 liters of solution. And it has 50 grams of glucose. Well, it doesn't have the number of moles of glucose, it just has the number of grams, so we've got to convert that to moles. So 1 mole of glucose is how many grams? 180.18 grams. How do I know that? That's the molar mass right there. The way you convert from grams to moles is you divide by the molar mass. So C6H12O6, 6 carbons, 12 hydrogens, 6 oxygens. That's the molar mass of glucose, okay? So if we take the 50 grams and we divide it by the molar mass, oops, sorry about that. If we take the 50 grams and we divide that by 180.18, we get 0.2775. Okay, remember the grams are going to cancel and you get moles. So now we got the moles, we got the liters, so we can do the calculation. Molarity, moles over volume, 0.2775. Remember, it's the moles of the glucose, which is the solute, divided by 2 liters of solution. Okay? So 0.2775 divided by 2, and you get 0.13875, which I'll round that off to 0.139. What are the units? Moles divided by liters, so moles over liters. Sometimes it's written with just a capital M. Capital M meaning molarity or moles per liter. Okay? So there's part A, which is find the molarity of a solution that has 50 grams of glucose into 2 liters of solution. That's a measure of the concentration. Now, in part B, it says we're going to use this solution and find the volume that would contain 0.25 moles of glucose. So what I'm going to do is I'm going to erase this up here. And then we're going to take that information that we have 0.139 glucose solution. And I'm going to say that's capital M for molarity. Okay? And then it says, what is the volume? So in part B, what is the volume if you have moles is 0.25? Okay, notice how I'm using the symbols V, N, and M like I talked about a little bit earlier there in that part A. So capital M equals N over V. So they're asking us for V. So what do we do algebraically? We multiply both sides by V. Right? The reason we multiply both sides by V is because if you do that on the right side, V divided by V is 1. So it cancels. And that's just equal to moles. Okay? Now, we're trying to find out the volume. So now what I'm going to do is I'm going to divide both sides by capital M. M divided by M is 1, so V equals N over M. Okay? Volume is moles over molarity. Okay? So all we got to do is take the moles, N, divided by molarity, and we got it. Okay? So we have moles is 0.25. Molarity is 0.139. Moles cancel and you get liters. Okay, so 0.250 divided by 0.139. Looks like it's about 1.80. Yeah, about 1.80. In other words, it takes almost 2 liters. 1.8 liters. We're using almost all the 2 liters that we had in part A to get 0.25 moles. Okay, so there's part B. And then we're going to come up to part C. It says the number of moles of glucose in 0.5 of this solution. Okay, so let's be careful here because I don't want to erase everything. So I'm just going to erase this. When they say this solution, they mean the solution from part A most likely. Okay. Okay, so part C, we want to find the moles of glucose. That's N. If we have a volume 0.5 liters. So implicit in that is that we're using the same solution, 0.139 moles per liter. Okay? So let's come back to this little equation. Capital M is very useful, N over V. M equals N over V. Just like density, D equals M over V, this is molarity calculation. If we're trying to find the number of moles, that's N. So what do? Multiply both sides by V. That gets rid of the V here, and now you got moles. Moles equals volume times molarity. Should get units of moles when you do this calculation. So we have 0.5 liters. And then 0.139 moles per liter. So it looks like you're just taking 0.139 and dividing it by 2, right? Multiplying by 0.5 is the same as dividing by 2. So 1.39 divided by 2 is 0.69. Looks like it's 0.69 moles. Oops, 0.069. Calculate the number of moles of glucose in 0.5 liters of the solution. Okay? And there you go. We got it. Part A, B, and C. It's all based on this idea of molarity. Important part of this is this moles over liters. So that's N over V. Using that equation, we can do all sorts of calculations.